Okay, here we go. We're ready to start with our lesson 2.3. Key concepts. The sine and cosine ratios compare the lengths of the legs of a right triangle to the length of the hypotenuse. So here's a right triangle. Here's an angle x that we're referencing. That's my 90 degrees, which means this must be hypotenuse. This is beside the angle that I'm referencing, so it's the adjacent. This is opposite the angle that I'm referencing, so that must be the opposite side. The sine and cosine ratios, they're two different ratios. The sine and cosine ratios can be used to find lengths of triangles and to find angle measurements. And we're able to do that without measuring with a protractor or measuring with a ruler. So this is very, very important. Very important for construction, very important for anything that you're doing in reality. Trigonometry is probably the area of mathematics that's most used in your everyday life. Okay, so example 1, using your calculator. We want to evaluate the following to 4 decimal places. Remember what evaluate means. It means to determine the numerical answer. So make sure your calculator's in degrees. So the first thing, and we're just getting used to this, we want to know what the sine of 47 degrees equals as a decimal. So on your calculator, at least with my calculator, I hit 47 first, so I set it 47, and then I hit sine, not sin. Sin happens in religion class. This is math class. Sine. So once again, 47, sine. That's the decimal I get. What is that decimal? That's the decimal I'll get when I take a triangle that has a 47 degree angle here. That's the decimal I get when I take this side length and divide it by that side length. I'll get this ratio. So it says to do it to 4 decimal places. So it's going to be 0.731. Now 7313. That last number is a 5. So if it's a 5 or greater, we're going to round up. So we're going to make that a 4. So that's rounded. And if we want to be accurate, we'll say that that's an approximate by putting a little dot above it. Just going to bring you in a little bit closer so we can see. They ask us to find the sine of 63 degrees. So 63 sine is going to give me 0.891. 8910. The next one is a 0, so it stays a 0. And again, it's still approximate, so I would rather have an approximate sign there. Now, some of your calculators will require you to hit your sine button first, then put in the 63 and hit equals. So if you're having problems with that, try that order and see if that works better for you. Again, what is this decimal? This decimal is, if I was to have an angle here of 63 degrees, then this side length, whatever its length would be, divided by the hypotenuse, that ratio would be 0.8910. That's what that would mean. No matter how big the triangle was, whether it was this size or I blew it up so it was bigger, as long as that angle stayed at 63 degrees, even though this side got bigger, this side would have also got bigger at the same ratio, so therefore when we divided them, we'll get the same decimal. Use your calculator to find an angle. So we're going to go the other way now. This is the ratio that they're giving us. We want to be able to go backwards and make sure that we can get the angle that it came from. So instead of doing this, let's look at this one first because we know what the answer should be. I should be able to take this value and go back and get 47 degrees. The way you do that is putting in decimal 7314. Then you hit shift. We want to go the opposite way. So we don't hit sine again. We hit shift, or in your case it might be second function, sine. And that takes a decimal ratio back to the angle, which is pretty much 47 degrees. Now it's not exactly 47 degrees because remember we rounded this. So this wasn't exactly what was when we did sine of 47 either. So there's going to be degrees of error, but they're pretty darn close. Let's look at this one. So 0.891, shift, sine, so going the opposite way, it should give me 63 degrees. And again, it's pretty darn close. It's not perfect because I rounded this. So I want to show you something that's happening. If we think about this process in our minds, we can think about taking a whole bunch of angle measures, so angles, or thetas if you will, and they're being moved to a ratio or a decimal. And that ratio or decimal in the sine function is going to be opposite side over the hypotenuse side, whatever that works out to. So when you use your calculator and you do sine of 47 degrees, what that does is it takes 47 degrees, you use your sine function, and it tells you that that ratio will be 0.7314 approximately. So then if I take 0.7314 and go backwards, so not using the same function but using a reverse function, we call that an inverse. Yes, we call that the inverse function. So that's sine inverse of 0.7314. And when you do that, shift sine inverse. Now remember, I hit shift to get the sine to the -1. That's inverse. It takes me back to 47 degrees. So what you have are two functions here. You have the sine function when you put in an angle, and you have the inverse function when you put in a ratio or a decimal. This takes an angle to a ratio, and this takes a ratio to the angle. Two different functions depending which way we're going. I'm going to stop there and then we'll come back to the lesson because I don't want to be making too many mistakes and having to redo a video. Well, actually, let's just finish here and then we'll finish off this video. So sine of A equals 0.9613. This is the ratio. This is the decimal that we get when we do opposite divided by hypotenuse. So this length divided by this length gives us this decimal. The question is, what's this angle then? If my opposite divided by my hypotenuse gives me this decimal, this ratio, what is this angle? Well, 0.9613, second function, sine, because I'm using the inverse of sine. So a way of thinking about this, and I think it's good if you start thinking this way and start writing this because it will make more sense, we get theta equals approximately 74 degrees. This one over here, cosine. Now that's a little different. So this is going to be adjacent over hypotenuse. Okay? So that's the decimal. It's adjacent, so it would be this side divided by this side. And we want to find this angle because it's adjacent to that angle, hypotenuse. So we're going to do cosine, the inverse, so cos inverse of 0.06976. So on my calculator, I have to put in the decimal first. Other calculators you don't. You have to put in the second function cosine first. Shift cosine. Oh, I think I put a 5 in instead of a 6. 0.06976. Shift cosine. And I come up with theta being approximately 86 degrees, if you will. Or they didn't use theta, they used A. This would probably be even better if I said angle A was equal to 86 degrees. And over here, they didn't use theta, they used A. So angle A is approximately 74 degrees. Okay, we're going to stop there and then we'll continue with the lesson.